Hello everybody and welcome. In today's video, we're going to be going over the quotient rule and we'll be going over these three examples shown on the screen. So without further ado, let's shake and bake. Example number one. So we have y is equal to this equation right here. So in order to show this visually, what I'm going to do is I'm going to label the numerator equation 1 and the denominator as equation 2. So the formula goes as follows. What we do is we'll take equation number 2, write it down, and then we're going to take the derivative of equation 1, and that is going to be subtracted by equation number 1 times the derivative of equation 2 all over equation 2 squared. Okay, so let's go ahead and set this problem up. What we're going to have is equation number 2, which is the denominator here. So it's x squared plus 1 times the derivative of equation number 1. So d over dx of 5x minus 2. And that is going to be subtracted by equation number 1, 5x minus 2, times the derivative of equation number 2, x squared plus 1. All of this is going to be divided by equation number 2, which is equation number 2 squared, which is x squared plus 1 squared. All right, so let's simplify this a little bit. On the left-hand side, we have x squared plus 1. Then the derivative of 5x minus 2 is just 5. And that is going to be subtracted by 5x minus 2 times the derivative of x squared plus 1 is 2x all over x squared plus 1 squared. All right, so now let's go on to the next page and finish this off. Continuing on, so all we have to do is simplify, and what we're going to be doing is distributing this 5 over and this 2x over to both of those numbers. So what we get when we do that is 5x squared plus 5 minus, I'm going to keep the parenthesis there, 2x times 5x is 10x squared minus 4x all over x squared plus 1 squared. Let's simplify further. So we have 5x squared plus 5 minus 10x squared plus 4x all over x squared plus 1 squared. I just distributed the negative sign to both of those numbers there. Now let's go ahead and combine like terms. I'm going to take this up here. So we have negative 10x squared plus 5x squared, which is going to be negative 5x squared plus 4x plus 5 all over x squared plus 1 squared. All right, so this is going to be our final answer since we cannot simplify more. Therefore, this is the derivative, and this example is complete. Example number 2. So we have this equation here. What I'm going to do first is label them. So equation number 1 and equation number 2. Also, another thing I want to note is that this term right here can also be written as x to the 1/3 power, which you want to do because it makes taking the derivatives and everything easier to visualize and understand. All right, so let's go ahead and continue with the quotient formula. So equation number 2 stays the same. x cubed plus 1. Then we take the derivative of equation number 1, and that is going to be subtracted by equation number 1 times the derivative of equation number 2, all divided by the denominator, equation number 2, squared, just like that. All right, so let's go ahead and simplify this. So our top, or the numerator, becomes x cubed plus 1 times the derivative of x to the 1/3 is 1/3 x to the negative 2/3 minus x to the 1/3 times the derivative of x cubed plus 1 is 3x squared. And that is all over x cubed plus 1 squared. All right, so now let's go ahead and distribute the numbers on the outside of the parenthesis inside. So looking at the top left, we have 1/3 x to the negative 2/3 times x to the third power. That is going to give us 1/3 x to the 7/3. When exponents are being multiplied to each other, you add them together. All right, so that's the first part. And now the second one is plus 1/3 x to the negative 2/3 minus 3x to the 7/3. And it's the same concept there. Those are being multiplied, so you add them together. And that is all over x cubed plus 1 squared. Okay, so let's go on to the next page and finish this. So all we have to do here is simplify. And when we're looking at this, we have two terms with the same variable and exponent, so we're going to go ahead and combine those. What we get is 1/3 x to the 7/3 minus 3x to the 7/3 is going to be negative 8/3 x to the 7/3 plus 1/3 x to the negative 2/3, and that is all divided by x cubed plus 1 squared. Okay, so what I want to do from here is I want to eliminate those fractions from the numerator, and we can see that they have the same denominator. So what I have to do is just multiply top and bottom by 3, which is okay since 3 over 3 is 1, and you can multiply 1 to your equation. But you just got to remember that the 3 that you multiply on top, you also have to do it to the bottom. So what we get here is negative 8x to the 7/3 plus x to the negative 2/3, all divided by 3 times x cubed plus 1 squared. So that 3 came because of that. Okay, so let's continue simplifying here. What I want to do is I want to factor out x to the negative 2/3. Okay, so whenever you're going to factor out an exponent from another variable with an exponent, I'm going to show you the math here on the top left. So you take the exponent that you are going to be factoring out of. So this is x to the 7/3. And what it is basically subtracting the other exponent. And in this case is negative 2/3. And what that's going to give us is x to the 9/3. So that's how you can tell what your exponent should be when you factor something out. Is you take the original exponent and then you subtract it from the exponent that you're factoring out. So what we get here then is negative 8 x to the 9/3 plus 1. And that is all over 3x cubed plus 1 squared. All right, so the last step we want to do is just make this exponent positive, and that is done by bringing it down to the bottom. So that means y prime, or our derivative, is equal to negative 8. 9/3 is 3, plus 1 all over 3x raised to the 2/3 times x cubed plus 1 squared. All right, so that there is our final answer, and this example is complete. Example number 3. So let's go ahead and label our equation. So the bottom one, I'm going to call that equation number 1, and the top, I'm going to call that equation number 2. So to do the quotient rule, what we do is we keep equation number 1, x squared, and that's going to be multiplied by the derivative of equation number 2, which is sine of x. And that's going to be subtracted by equation number 2, stays the same this time, so sine x times the derivative of equation number 1, ddx of x squared. That is going to be all divided by equation number 1 squared, so x squared squared. All right, so let's go ahead and simplify this. So x squared, the derivative of sine x is cosine x minus sine of x times the derivative of x squared is 2x, all divided by x squared squared is x to the 4th. All right, so let's continue simplifying here. We got x squared times cosine. I'm just going to write it without the parentheses. So x squared cosine of x minus 2x sine of x, all divided by x to the 4th. What I can do here is factor out an x from the numerator. So we got x cosine x minus 2 sine of x all over x to the 4th. And now I can just simplify further by eliminating the x on the numerator here and changing that to an x cubed. So we got x cosine x minus 2 sine of x, all divided by x cubed. All right, so that is our final answer here. Therefore, this example is complete.